Example 5, here's g of x, and we're going to sketch this. G of x will be 4 if x is not equal to 1. And then g of x will be negative 4 if x is equal 1. I really can't call this a left and a right piece, and you'll see why when we get the graph complete. So just know that we'll have to keep paying attention to where we're going to graph what piece all the time. So let's look at this. We have y equals 4, and we know that that's a constant function. It's a horizontal line. Everywhere where x is not equal to 1. Okay, so here's x equals to 1. Let me just go ahead and write down a little bit of a scale here on the x-axis. So everywhere y equals 4 except there, and I'm just going to designate that with a hole. Everywhere else I have the horizontal line y equals 4. So I'm going to show that piece like that. Then the other piece, well, it says y equals negative 4 if x equals 1. So I just have the point 1, negative 4, and I'll designate that with a filled in circle. So that is the complete picture of the graph of g of x here. So is g continuous on its domain? Well, absolutely not. So no, because if I were to trace this graph, then I would start from values, negative infinity values in x, and I would go along on the constant function. But when I got to the value x equals 1, I'd have to jump down and fill in this point down here at negative 4, 1, negative 4. Then I'd have to jump back up and trace up at the value y equals 4 again. So g is not continuous on its domain.